So DeepSeek, I mean, the industry over rotated a little bit on that, but there is a message there that matters, which is this is an incredibly complicated and complex computing problem. And in computer science, the way you solve incredibly complicated, complex problems to start with is brute force, where you use brute force algorithms, and you start with that. What we're seeing with algorithms and improvements like DeepSeek, and there will be others, is we will see good computer science come in, and we will see improvements in those algorithms. And quite often you can get very large speed ups and very large efficiency gains by just simply using better algorithms. And this is, for me, as in my background as a computer scientist, that's where I think there's going to be a lot of interest in this space. Now, invariably in those things, that is, there's going to be trade-offs in those algorithms. There's going to be improvements. There's going to be blind alleys that the industry looks at. But yeah, I'm actually really encouraged by it. To me, this tells me that some really, really smart people are starting to get involved and looking at it from an algorithm design point of view, which I think is, again, very interesting from a computer science point of view. So I'm actually really encouraged by it. I think it's actually I think it's a sign that the industry is maturing a little bit, that we're starting to see these kinds of incremental advancements in algorithm design.
Yeah, and I'm going to also add on to that as well. The idea when this first came out, I think all of our phones kind of blew up that, oh, China's got something and it's going to be really bad for everybody. And very quickly, if you started looking at it, open source is very positive, and NVIDIA was very positive about it. And as people really looked at it, they said, well, hey, this is just a far more efficient way to run some of these workloads. And I think everybody's looking for some type of increased efficiency. And, there's a term that, I've seen batted around a lot, which is Jevons Paradox. And if you look at Jevons Paradox, they kind of talk about increased efficiency can lead to increased consumption rather than decreased consumption. And so this started with, coal when they did it. It was semiconductors. It was cloud. I mean, you see all these examples of this. So I think there's nothing to fear here. And I think, in fact, it'll end up being, more efficient for us to run in the long run as we're all learning how to do this. And I think you can only look for people that continue to try to innovate and make this better. And I think it'll just ultimately lead to more increased consumption as we talked about. So I think it's an interesting time. I think we're only at the beginning of how people will innovate, trying to make this either more cost effective, more efficient. You can't just continue to have runaway costs in this space. I think it's got to be brought down to reality fairly quickly in this as well.
Well, Chris, another thing that you mentioned that I wanted to touch on, but I'll flip the question over to Don. You mentioned how, lessons learned from the cloud period. You could talk about cloud, you could talk about virtualization, you could talk about edge. What types of lessons learned from those eras, so to speak, should we be applying to AI workloads, recognizing the fact, Don, that early on you said these are just different beasts, AI workloads? Are there lessons learned there?
I think there are.